Hi everyone, good afternoon. My name is Eunice Silva and I'm here to tell you a little bit about our journey into wave energy. So part of the clean energy mix and something that is very exciting. So CorPower is a Swedish company. We started in 2012, so we've been on the journey of wave energy for more than 10 years now. We are a company that builds technology, so we're a turnkey technology developer. And we have been building our wave energy converters in partnership with the health and partnership with also energy company and suppliers. So we are about 75 people. We are from 40 different countries. So we have lots of people thinking of how to bring the technology to the market, how to make it work. Super important. And we are based in different locations. So thinking about the opportunity, so wave energy. So it's about 500 gigawatts of wave energy out there to be used, and it's important to find a way to use it. So if you want to think of where are good ways to harvest wave energy, think of where are nice places to go surfing, and those are the locations. So in the coast of Portugal, Spain, Ireland, in Norway, also the Pacific coast, there's a lot of potential. So any place that has a good swell wave energy, it's a good place for harvesting wave energy. So there's a lot of potential to be used here. So what's the challenge here? The ocean is a harsh location to go and put a machine to harvest energy, to make electricity. So it's a big challenge to have something in the ocean that is not completely destroyed after a big storm and that can actually produce power with a smaller mass as possible and a smaller investment as possible, so that you can make it something that it's compatible. So thinking of wave energy and how it can be an advantage, if you look at, for example, this is a case from California. You see the gray part of the graph is solar energy. Of course, only during the day you have the production of solar energy. Winds, you can see the wind case here at the bottom in blue. And the advantage of wave is that it can provide consistency to the grid. So if you have a mix of renewable energies, that you have solar that is only producing during the day, and then wind that's producing less reliably, and then wave energy can create a reliability in the mix. So the grid will not have to have so much storage, which is very expensive. So looking at wave energy, there is a lot of potential, but the difficulty here is to have a machine that actually works. There have been very many unsuccessful cases of wave energy. And what we're trying to do is to have a machine that works, that can produce energy and that can be reliable and work during the harsh storms. So it's quite big. So it's 19 meters tall, the buoy, and 9 meters wide. So it's a large buoy and it's rated at 300 kilowatts. And I think we can skip the video and I continue talking. Yeah. Okay. Yeah. And you can go to our website, put videos there. I don't think and I'm good. Okay. So just a few key numbers on our device. So this is the buoy that you've seen over there, and it's a buoy that it's made out of composite material, and it has a power takeoff inside. And then you can see that how it works. So it's connected to the seafloor where it is connected to a cable that is connected to a substation onshore. And then you have the buoy that it's heaving up and down with the motion of the waves. And then what we have is a machine that it can be tuned and detuned. So this means that when there is a storm and there are very large waves hitting the machine is detuned, so it's not in sync with the motion of the wave, so it does not heave as much. So there's a lot less loads and the probability of surviving is much, much higher. And then when there's a regular wave condition happening, the machine is tuned with the waves, and this is achieved by a pressure system inside the buoy that is connected to the power takeoff. And this pressure system has a control algorithm that it's in sync with the incoming waves. So it's measuring the waves every second. that it's the incoming wave, and then this motion is amplified of the buoy. So the buoy with a 1 meter wave will heave about 3 meters up and down. And then this motion of the buoy in those ocean rods that you see there is then connected to a gearbox that turns this vertical motion into rotating motion that then generates electricity. That it's then connected with cables through here up to shore with to the substation. And then the machine is made out of this composite buoy. And then there's a mooring rod and a tidal regulator because the tide will vary. So there's a motor inside this piece of the equipment that will make it move up and down so that the buoy is in the optimal surface location for the electricity production. So we've been developing the technology since 2012. And we are now on our stage 4. So our full-scale device, our prototype, that is going to be deployed in Portugal very, very soon. So we've been working very hard for a long time to make this happen. And I'll skip that part and just show you. So this is actually our machine hall here in Stockholm, where we built the device. So the power takeoff of the machine has been built here in Stockholm. These are the ocean rods, and this is our team assembling the power takeoff here in Stockholm. So after assembling the power takeoff of the C4 device, the wave energy converter, we have passed on to the next phase, which is the dry testing. So if you want to deploy a machine this size in the ocean, you want to make sure you de-risk it as much as possible. And of course, you want to test what are the conditions that are going to be the harshest on the machine. So we have a dry testing facility here in Stockholm, in Västberga, where we can simulate any ocean conditions. So we have this very large generator. You can see the blue boxes over there that can produce the power of a large storm on the machine. So what we have done is we set up the power takeoff, and what you see, the structure around it, blue and yellow, is a mock hull. So it's to pretend that the actual composite hull that is so large is on the power takeoff. And then we could see the power performance of the device and how it would respond mechanically, all the important parts of the generator of the energy, if there is a large storm hitting the ocean rods and the machine. So we've done the dry test phase, and then this is the location in Portugal where we are deploying the wave energy converter. It's in Agosadora in the north of Portugal, and there's a substation here, and then the machine is about 5 kilometers offshore, because that is the optimum location with a depth of around 40 meters. So we have shipped the power takeoff to Portugal, and one important thing in our development is that the composite buoys, you've seen the big buoy around, they are made by a mobile factory. So if you want to build in the objective of scaling this technology and building these very large buoys, we don't want to ship them to different locations around the world. So what we ship is the mobile factory that has a winding cell, and I'll show you now, that makes the hulls. So they're made out of these fiberglass composite materials. And then it's a winding machine that makes it in different layers. And then we come up to this, this is the finished composite hull. That's the buoy out of the machine. So then the factory in the location where the potential wave farm is going to be located, then produces 1, 2, 3, 50 of these composite hulls. And then the power takeoffs can be shipped because they are smaller and they can be shipped in a mati, in a ferry, in a road, so it's much easier. So a little bit of what we've done now in Portugal. Last summer, we have deployed this very large cable, the 6 kilometer cable from the substation on shore all the way to the site. So we had to horizontally drill under the beach and install a tube, and we then installed the cable with a vessel all the way to the location where the machine is going to be located. And we have also installed the anchor that's holding the machine on the seabed. So we also had to develop an anchor that is called the UMAC anchor for sandy soils. So after the installation of the anchor and the cable last summer, we have now come to a point where we have the full complete machine assembled in the port of Viana do Castelo. So this was a few months ago. Then we have the buoy with the power takeoff inside and the mooring rod and the tidal regulator. And we have now done some tow testings. So we have actually successfully put the machine in the water and we have towed it to the site. We're going to install it. Of course, things connected to the ocean have challenges and we have faced challenges and we had to return back to port and not install the machine, but we are now working on the final details and making sure we have everything in place. And we hope in the next couple of weeks, months, we will be successful in deploying our prototype C4 machine and actually having it connected to the grid, producing electricity in Portugal. Just a little bit on our concept. So what we aim to do is to produce energy at the grid scale level. So we want to have several of these devices connected together so that you can produce enough energy because they're rated at 300 kilowatts. And what we want to have is the core packs. So they are these are. So the core packs will be about 10 megawatts inside. So that's about 28 devices connected to each other and connected to a collection hub. And then this collection hub can be connected to regular electrical infrastructure. So for example, you can have an offshore wind farm and a wind farm combined together using the same infrastructure to connect it back to the grid. So then you can have several synergies with other renewable technologies in the marine space if you're using the same infrastructure, the same space, the same licensing. In terms of project development, there are a lot of advantages in that sharing. Just an idea of space and size. So you can see here a floating wind turbine, and you can see there a CorPower Ocean wave energy converter, just for an idea of scale. And if you're at the beach and you have a wave farm away 5 kilometers, and this is what you would see. So the visual impact is not very high. And that's something I think that is very important. People at the beach don't want to see something in front of them when they're sunbathing. Just to explain our business model. So we are a turnkey technology developer. So what we do is we provide technology and then we provide engineering services for the maintenance of the technology. That is the end of my story. I'm not sure if I took more time.
No, that's wonderful. It's such a wonderful story.